All right, so that question last night was a great question.
Yeah.
So we might write down the rational numbers. Give me a rational number that you know, an easy one.
Oh, half.
A half. So maybe our first one is 0.5. Yeah, let's try to keep them 0 point something, just the same as we did before. Just keep that simple.
But 0.8.
0.5000000.
But 0.8. Or like 81 or something.
Okay.
0.81.
0.81. You know that's rational. How do you know that's rational?
Because it stops. The decimal stops. Also, it's 81 over 100.
Okay. Give me a third rational number.
0.3 repeating.
Oh, 0.3 repeating. Good one.
That's
So rational numbers don't always have to end with these long trailing zeros.
Yeah.
Okay.
How about 0. 09090909.
What is that rational number?
I think that's 1/11.
1/11. Yeah, because when you multiply the 9s by 11, you get 99. You get
Yeah.
0.999999.
Which is wrong.
Okay. So now we have the whole list. So we just fill it up. Whole list of rational numbers. Or even if we just want to restrict it from 0 to 1, or if we wanted to not restrict it from 0 to 1, we could always make the digits up out here, the integers as well. In any case, we could do the same thing. If it's an 8, well, what do we have? We have 5, 1, 3, 9. Okay, so let's say if it's a 3, make it a 7, and not 3, make it 3.
3.
Okay, so we would get a number that looked like this: 0.3,
3,
3,
3,
7,
7,
3.
3, and so on.
Yeah.
And is this number on our list?
No, because it would be different.
Right, it's different.
Like we said before, it's different from each of the numbers.
Right, it's different from each of those numbers. So it seems like we have created a new number that's not on the list. What's the problem?
This number goes on forever, doesn't it?
It would go on forever, and it would be this weird mix of 7s and 3s.
It might not be rational.
It might not be rational.
So you.
In fact, rational numbers are always either going to end in a bunch of zeros, or sorry, a repeating digit,
Yeah.
Or like some sort of pattern like this.
or some sort of repeating sequence.
But this is just going to be depending
this is
on what
random.
order you put them in.
Right, this is going to be just a random sequence of 3s and 7s.
So it's might not be rational. Or,
It might not be rational. In fact, it's very likely to not be rational.
yeah, unless
Yeah.
you put the numbers in an order.
Yeah, so that's exactly the point. If could you arrange the numbers in an order that would make this number rational? And I don't think you can. But that's probably pretty hard to prove. But that's the answer to your question, is when you do the diagonal argument, you get a number that's not on the list, but that number's not rational.
Yeah.
Okay?
Yeah.
All right, so that's interesting. And now I'm going to show you something even crazier. Well, first I'm going to show you the proof of why the rational numbers, you can count them. And I'm going to show you something completely crazy after that.
Okay.
Okay?
Alright.